Our aim today is 11.7 linear and quadratic regressions. Your homework is Delta Math SPR. So I'd like you to show the computations and how to get the answers algebraically. Simply stating that you used a table is not sufficient. Credit will not be awarded for that. So I'm going to teach you how to derive these equations or how to rather get these equations in your calculator. But then when it comes to applying those equations, you'll have to show your work algebraically. So regressions. Oftentimes in science, a mathematical relationship between two variables is desired for predictive purposes. In the real world, the relationship between two variables is not always a perfect one. Thus, we often look for the best curve that can fit the data. So here's some vocabulary. Scatterplot, a graph that relates two sets of data by plotting the data as ordered pairs. Correlation, the strength of the relationship between data sets. Trend line, a line that approximates the relationship between the variables or data sets of a scatter plot. Use trend lines to make predictions about the data. Line of best fit, the trend line that gives the most accurate model of related data. And your correlation coefficient. It indicates the strength of the correlation. It's represented by the variable r. The closer r is to 1 or -1, the more closely the data resembles a line, and the more accurate your model is likely to be. So if we look here, you can see at the top box, this would be considered a high positive coefficient. Notice how the numbers are closely clustered together. That's a strong correlation. And notice how the slope is positive, so it's a strong positive correlation. Here in the second, you can see that they're more or less going in the same direction. However, it's not as strong, so that is a weaker positive correlation. Over here, we have no correlation. Below, we have a strong negative correlation. And in the bottom, we have a weaker negative correlation. So a linear regression. The number of newly reported crimes in the county of New York State is shown in the accompanying table, where X represents the number of years since 2006, and Y represents the number of new cases. Write the linear regression equation that represents this set of data, rounding all coefficients to the nearest tenth. Using this equation, find the projected number of new cases for 2014, rounding to the nearest whole number. So how do we find the regression coefficient? Please view the following video. Okay, so how do we enter this information into our calculator in order to generate a regression? So the first thing we're going to do is we need to get our regression coefficient. So before we do that though, we're going to clear our calculators of past numbers. So there are a few ways that we can do that. I'm going to show you guys one way. So we hit the word stat, and then we're going to hit number 4 for clear list. And now we need to tell the calculator which list. So the last time we filled lists 1 and 2. So we're going to hit second L1, comma, second 2 for L2. And we hit enter and done. So now our lists are clear. So in order to begin, we need to also determine how strongly correlated our regression equation is to the actual data. Is it a strong correlation or not? So to do that, we need to figure out what the correlation coefficient is. And so this can be accessed a number of ways. So the first way that you can access it, depending on the calculator, you may see these options, or you may have to go about it in the second way, which I'm about to show after this one. So first we're going to go to mode. So I'm going to clear this here to reset, and we're going to go to mode. And we're going to scroll down to where we see stat diagnostics. And we're going to hit on for stat diagnostics. We're going to make sure it's highlighted, and then we hit enter. And at that point, we can hit clear, and it brings us back to our main page. But now our stats diagnostic is on, and you can verify that by going back to the menu and seeing that it's highlighted as on. Okay, so I'm going to clear this way because let's say that you don't have that as an option. Well, here's another way. Here's another way that you can do that. So we're going to go to our catalog. And if you'll notice, the catalog is located just above the 0. So we're going to hit second 0. And we're going to look for the word diagnostics on. So now notice that A, there's a little A in the corner, that means that it's alpha. So just like a dictionary it's ordered in alphabetical order, we're going to do the same. So we need to look for the word diagnostics. So we're going to go to D. And when you look at your calculator, you'll see x to the -1, and you'll see a green D over that. So we don't have to hit alpha, it's already pre-selected. So we're just gonna hit that button. And now we are at everything that begins with the letter D. So now when we scroll, you see the term diagnostics on, or diagnostic on. You hit enter one more time, and now your diagnostic is on. So those are the 2 ways that one can turn it on. Okay, so now how do we create a scatter plot now that we have our stat diagnostic on? Okay, so now we need to enter in this information, and we're going to use this to create a scatter plot. So now we're going to hit the word stat, and we're going to enter in our list. So I'm going to just start entering in lists as we had it. So now that I've entered in the list, I'm just going to double check to make sure that I entered all of the information as it appears on our given table. And so far, it all looks good. Okay, so how do we create a scatter plot from this? So I'm going to clear below again so you guys can see how we create a scatter plot. So we're going to hit second y equals, because you'll see there in blue it says stat plot. And we are going to turn on the first one. Notice that says plot 1 off. So we're going to hit for plot 1. And notice all our different options. We're going to hit enter because we want to turn it on. And you have so many different types of graphs that can be drawn. For example, you might even notice the box and whisker that's there. So we're going to leave it though with the scatter plot. And now we're going to see what that graph looks like. So in order to do that, we're going to hit zoom, and we're going to go down to number 9, zoom stat. And when you see that, that is your scatter plot. And we are asked to do a linear regression on this. So how do we do a linear regression? So how do we determine now a regression equation? Okay, how do we do a linear regression? So using the information in this um, in this data, we're going to use our calculator to determine how we get a linear regression. So again, we're going to hit the word stat, and now we're going to go over to calculate because we still have our information in our lists. And since we were told that we wanted to do a linear regression, we're going to go down to number 4. Now, if you'll notice that choice 4 and choice 8 are similar, they're both called linear regressions. We tend to go with choice 4 because you guys are used to the form y equals mx plus b, where you've got the coefficient in x first, followed by the constant. So we're just going to keep things as they usually are. So we're going to select choice 4. So here, our first should be the year since 2006. Our y list should be new cases. However, we don't need a frequency list, so we're going to clear that. And now we're going to calculate. You could store your regression equation. It's not necessary, but you could do so. So if you only see the words lin reg, what you'll have to do is you'll have to hit second 1 to get L1, comma, L2. And that will also calculate your linear regression. So now we go down to calculate, and we hit enter, and look at that. This would be our linear regression. And it's negative 4.25142857 approximately. And we also have our B. Notice that this R here, that means that this is our correlation coefficient. Notice how it's negative 0.9775. That means that it's a strong negative correlation, meaning that the slope is going downward. Now, if you wanted to see what this would look like as a graph, I'm going to show you guys. Again, this next part, it's not necessary. I'm just showing you what this would look like. If you're ever curious, you could actually just type it in. You know what? I think I'm going to type it in. I think I'll just type it into our Y1 instead of going about it the other way. So we were asked to round all coefficients to the nearest tenth. So let me see. We're just going to quit out of here because I did not write it down what our regression was. So when we do this, let's see, sometimes, here we go. Okay, so I'm going to type this equation into our calculator. I'm going to round everything to the nearest tenth. So that's going to be negative 42.51. And, oh wait, I put minus. Let me delete that. Okay, 42.5 plus, oh, excuse me, x. No. Sorry, guys. Negative 42.5 x. Oh, I keep doing this. Sorry, I'm trying to type on my keyboard, and it's just not having the same effect as me punching it into the calculator itself. Plus 789.6. Okay, so now I want to compare what that would look like with our scatter plot. So I'm going to hit zoom again. I'm going to hit zoom stat. And this would be our regression equation, our linear regression equation. Okay, so now we have our solution, and y is approximately 450. And you can tell what it would look like when it's with the graph and the scatter plots. So now, what about a quadratic regression? Well, a rocket is shot off from a launcher. The accompanying table represents the height of the rocket at given times, where x is time in seconds and y is height in feet. Write a quadratic regression equation for this set of data, rounding all coefficients to the nearest hundredth. Using this equation, find the height to the nearest foot at a time of 1.5 seconds. So we'll do the same with our regression. However, because it's a quadratic regression, we're going to hit choice 5 when it comes to calculating. And when you enter in all the information, they give you your A, B, and C. And when you enter this in, you get that y is approximately 312.